Welcome to this video tutorial on using skeletal animation for characters in Java. In this tutorial, we will explore how to implement skeletal animation to create fluid and dynamic character movements that can enhance your game or simulation. Let's dive right in. First, let's understand the concept of skeletal animation. Unlike traditional frame-by-frame animation, skeletal animation is a method where a character's movements are controlled by a skeleton of bones that can be manipulated. Each bone influences the positioning of vertices, allowing for more efficient and realistic animations. To work with skeletal animation in Java, we'll be utilizing a popular library called libgdx. If you don't have it set up yet, head over to the libgdx website and follow the setup instructions to create a new project. Let's start by creating our character model and exporting it. You can use tools like Blender. For our example, we'll create a simple humanoid character. Here's a brief workflow to follow. 1. Open Blender and create a simple humanoid character with a skeleton made of bones. 2. Rig the character so that the bones control different parts of the character. 3. Animate your character using keyframes in Blender. 4. Export the model and animation as a .png and .atlas file or a .gltf file that libgdx can utilize. Now, once you have your model ready, let's import it into our libgdx project. To do this, we will use the asset manager that comes with libgdx. Here's how to set it up. In the code snippet above, we are creating an instance of asset manager and loading our character's skeleton JSON file. This file contains the details of the skeletal structure and animation we created in Blender. The next step is to create the skeleton and the skeleton renderer that will display our character. Here's a code snippet that shows how to do this. In this block, we create a skeleton JSON object to read the skeleton data from our JSON file, instantiate the skeleton using that data, and create a skeleton renderer instance that will let us draw our skeleton on the screen. Now, we will write the render method to display the skeleton. This method will include configuring the camera, clearing the screen, and rendering the skeleton. Here is how you can do it. In this render method, we are clearing the screen and then drawing the skeleton using a sprite batch. Don't forget to create your sprite batch and set up the camera in your class. Next, we want to animate our character. To do that, we need to define an animation object and update the skeleton's animation in our render method based on elapsed time. Here, we create an animation object from our animation frames and keep track of the elapsed time. In our render method, we update the skeleton's current animation based on that elapsed time. Now, let's delve deeper into managing the animations effectively. You might want to control switching between different animations based on user inputs. Let's set that up as well. In this snippet, we check for keyboard inputs to change the character's animation. Pressing the up arrow key will switch to the walk animation, and pressing the down arrow key will switch to a run animation accordingly. Additionally, you can blend animations for smoother transitions between states. To do this, you will utilize mixed durations. Let's see how it's done. In this example, we are setting the animation to run and blending it with the previous animation over 0.2 seconds. This blending allows your character to transition more smoothly from one action to another, enhancing realism. Now that you can animate your character, let's enhance the visual aspect using shaders. Using shaders will give you fine control over how your character looks, with effects like lighting and colors. In libgdx, you can create a custom shader with GLSL. In the snippet above, you define both vertex and fragment shaders using GLSL. You will need to provide the correct shader source code. After creating the shader program, you can apply it in your render cycle to affect how your character is displayed. Make sure to unbind your shader after rendering to avoid affecting other objects. You can unbind it by invoking shader.end in the appropriate part of your render method. Now, let's talk about controlling character behavior. Often, characters need to respond to the game world. You can include logic that reacts to collisions or other interactive elements. In this logic snippet, we check if the character collides with an obstacle. If it does, we change the animation to idle. This kind of behavior helps create more engaging and interactive games. As we continue to enhance our animations, consider incorporating IK, inverse kinematics, for more advanced character motion. IK allows you to manipulate the endpoint of a limb and let the system calculate the position of the adjacent joints. By setting up IK constraints, you can create lifelike movements for limbs, making your characters appear more natural as they interact with the environment. Finally, remember to optimize performance. Skeletal animation can be resource-intensive depending on how many characters you have on screen at once. Use techniques like pooling for your character instances to manage memory efficiently. With pooling, you can reuse character objects instead of constantly creating and destroying them. This reduces garbage collection and keeps your game running smoothly. Finally, make sure to dispose of resources properly in the dispose method to avoid memory leaks. And there you have it. We've covered everything from setting up skeletal animation, managing animations, utilizing shaders, and optimizing your character animations. Armed with this knowledge, you should be ready to implement your own skeletal animations in your Java projects. Don't forget to check the description for additional resources and links to the tools we discussed. If you found this video helpful, please give it a thumbs up and subscribe for more tutorials. Leave your comments below if you have any questions or topics you'd like us to cover next.